Good afternoon, everyone, and welcome to the talk about interesting security patches that Microsoft released in the past 2 years. Now, most people make mistakes and learn from them. And in this talk, I'd like to show you that Microsoft is no exception, and the patches that we release are a lesson for us that we apply in our daily job. My name is Wroblewski, and I am security researcher working with Damian Haas and Microsoft Security Response Center. And, I really like breaking software. And not only software, hardware too, although my son is much better on that one. I also like breaking wood, concrete, etc. And as you probably have guessed, I come from Pakistan. When I got my PhD in Pakistani Institute of Technology, and I belong to the same tribe as Joanna Rutkowska and the famous LSD guys. So at Microsoft, most of the time we break software. And in my team, it all starts when a security vulnerability is being reported externally or found in the wild. And my job is to investigate the problem, find variations, take care of proper patch development process, and even verify bulletin. The goal is always to keep the customer secure. So that's the one part that I described, we call it the reactive part, but we also have a proactive part where the lessons that we learn from patches developed, we apply to the new products, and we apply as changes to our development process. Today I'd like to talk about 5 cases that were really good lessons for us, and you may notice that some of these cases made headlines at their time and were quite famous. So let's start from the quite very well-known case. And I remember it was December 2005, the Christmas time. My wife was making pierogi, borscht, and I put Christmas tree, kids were singing carols, and then, comes this big old jelly man and brings presents. And, he comes every year and brings something for the good Microsoft guys, but on that year, he misplaced our present, and he brought it to someone, I think, in Pakistan. So, fortunately, the guys from WebSense, they found this present and they reported this to us, and they said, hey, when you go to this link, there is this strange file, it's WMF picture, and it executes code in Internet Explorer. And we said, okay, this is not correct. It should not work like that. So we started investigation, and it quickly turned out that there is a code execution, in fact, and it goes from this function pointer. But how it happened, it's like pretty obvious feature, and how it happened that we missed this. And in fact, we released a security patch in October 2005. So somehow something went wrong with our process, and we still didn't catch the feature. And it turns out that this feature was introduced very early in the development of Windows operating system, back then when the Windows was 16-bit, the entire Windows was in 16-bit world. And this feature was about printing. Printing pictures in early 90s could take a long time on a computer. So we added this feature for applications to register function pointers and allow them to abort the printing operation. Now, the way that the pointer gets set from the picture file, it's not that simple. You get the main loop drawing the picture, you have one function, another function, then yet another function, and finally the pointer gets set. Then we go back to the loop where the malicious code gets executed. Now, you could understand that in a 20 years old code, it's obvious that people can miss this kind of feature still being present. But if you look at the picture file, the structures that describe this behavior are really simple. And that was the key learning for us. Basically, we decided that we must test the program with all the data that program can handle. In security research, we call it proper fuzzing coverage. So from that time, all our fuzzing must cover all data types that a program or feature can handle. And as an example, I could give you another file format, which is really also very old, the EMF file format, where in 2005 we were working on the part of the GDI component that is processing these picture files, and since then there was not a single security patch in that area. And so we applied the same process to other areas as well, and that was the first learning. Another learning was that the old features can really hurt us, but we cannot just remove them because people use them and customers want them very often. So you probably noticed that in Windows Vista, many legacy features were either removed or blocked in some way. Now, the next case that I have is was reported to us by Andreas Sandblad from Secunia, and it was a code execution in create text range. And you can see that the code that was responsible for the problem is quite simple. And basically, most people who saw this code, they said, "Oh, there is no bug in this code. There is no security issue." And in fact, the bug that you can see is the only one is that when going through cleanup label, the two error code paths, only one sets the error code, which means that the function returns success while it's not performing any function, anything useful. And in this case, the useful thing was setting ppdis pointer to something useful. So now you can think how this is a problem, right? And it turns out that it is a problem because it just happens that there is a code that relies on this error code value being returned, and if the code returns success, then it tries to use the pointer which was not initialized. So that means that we can execute code on the heap, and when the heap spraying methods became popular, this kind of bugs just happened to be very, very serious. In fact, I own this case, and I was looking for similar problems, and I couldn't find them. But you know, it's not easy to scan thousands or hundreds of thousands of lines of code. So I scanned just the area nearby, and there was not a single problem. And this issue was being actively exploited. So we had to release a patch. We couldn't wait until I scanned the 100,000 lines of code or someone else. So we released the patch, and a few months later, Andreas came back to us and said, "Hey, there's another bug," and it was almost exactly the same bug, only in completely different place of Internet Explorer. So what happened since then is that we improved our static analysis tools, and now we can detect similar issues at the code development time. It's most of the time it happens when the binary gets built. And as far as I remember, we did find problems of this class of problems in Vista, and we fixed them. Now the next case, I remember this one. It was handled by Damian, and I remember the day where the case came in, because Damian just sat down in his office and he was just looking at the monitor with this painful look, and You know, he just looked like a guy who looks at a girl knowing that the girl doesn't love him. And finally he asked for help for some other partner from our team. And together they figure out what the problem is. And if you look at there's obviously the function wsprint that looks suspicious at the bottom of the slide. And we have some buffer and the registry functions that read a key. But if you check the documentation, everything's all right. The buffer size is 360. Attacker does not control the registry database. The key name is limited to 255 characters. So there is just not there's no problem in this code. But yet the overflow somehow happened, and it was reported by EI to us. So they know what they're doing. And what happened is that the API that we are calling is doing more than we suspect. Basically, we are making some assumptions that are not in the MSDN documentation, but actually maybe no, they are not. They were not there back then. So the API was just removing trailing backslashes from the registry key name, and if the key did exist, it would return success, which means that you could create and pass key of any length and still overflow the buffer. And in this case, we cannot just change API the way we want in a security patch very often, because that changes functionality, and people complain that compatibility is broken. So but obviously just get rid of all those unsafe string processing functions. So we initiated the so-called banned APIs effort, and last year John Lambert from Microsoft during BlackHat was talking about this. Basically, during Windows Vista development, we had a huge list of banned APIs, and again, the usage of these APIs is being detected during the build process. So the next case started when we released a patch for a buffer overflow. And you see the patch right now. So the patch was just a simple check preventing buffer overflow from happening. And attacker controlled the length of some data that was being passed, and we had to prevent the overflow from happening. So you may think, man, these Microsoft guys are dumb. They can't even get this simple check right. But you know, let's see how the check really is simple. So you know, this total space available thing, it unfolds into something more complicated, and then even something more complicated. And you know, I handled this case. So the first time I saw the code, because you know, in Pakistan we teach children hexadecimal and binary first and decimal later, so I decided to just evaluate it in my head, the value. So I started like 4096 is 1000 hex, minus 8 is FF8, minus the size of cpage info, which was something like 52, which is 34 hex, that would be FCC, and things like that. So I came up with some value, and we started our testing process. But eventually what happened is that we should have looked at the assembly. And in assembly, this complicated expression became just simple value